Welcome to Unchatted Waters. In this episode, we talk about one of the greatest challenges of our generation, climate change. More specifically, we learn about how temperature changes impact the ocean and how we can come together to adapt to the changes we're seeing now to protect our future. If you'd like to learn more and hear interesting stories on how we can tackle this challenge, then this is the episode for you. Welcome to Unchatted Waters, the podcast that talks to the people behind the science. I'm Kirsty, your host. I'm excited to introduce my two guests for this episode. John Pinnegar is a world-leading climate change scientist and advisor. He combines his expertise in food webs and ecosystems with climate change to understand the risks to domestic and international fisheries. Susana Lincoln is a senior climate change scientist. Her research involves climate risks to marine and coastal environments and the interaction with other human pressures such as marine litter. Welcome to the podcast.
Thank you, Kirsty. Happy to be here.
So my first question is for you, John, and it's quite a big one. What is climate change?
When we talk about climate change, we're really talking about long-term changes in environmental conditions. So not short-term things like weather over the last year or month or day, but typically over decades or even centuries. And we've sort of monitored temperature and other climatic variables for probably about 200 years now. And over that time period, we have seen significant changes. But here we're really talking about impacts that have been caused by humans. Climate has always varied. We've seen, warm years, cold years. Here we're looking at long-term trends, particularly since the Industrial Revolution in the early 1800s. Humans have been releasing carbon dioxide by burning fossil fuels since we really went into the machine age. And that carbon dioxide in the atmosphere causes warming of the planet, greenhouse gas warming, if you like. And so that is what we mean by anthropogenic, so human-caused climate change.
Just for our listeners might be of a younger age group, how do greenhouse gases warm the planet? Let's go back to school.
Yeah, when we talk about greenhouse gases, really we're talking about things like carbon dioxide, methane, nitrous oxide, and a few other gases. And when they accumulate in the atmosphere, the sunlight comes in, it goes through the atmosphere and bounces off the planet, and then it gets trapped by this layer of gases in the upper atmosphere. And so that sort of area between the Earth and the atmosphere warms up. And as we get more of those gases in the atmosphere, then you get more warming. And a lot of that heat then goes into the oceans, which acts as a huge sort of sink, if you like, of the temperature, but also the gases. And that's why the oceans also warm up, sometimes by even more than the atmosphere.
So when you refer to a sink, what do you mean?
Yeah, so when we talk, in science we often talk about sources and sinks. So a sink is where either carbon dioxide or heat is taken up, and a source is where carbon dioxide or heat is given out.
So if we've been measuring temperature for over 200 years, how did we start and how do we measure the temperature in the ocean at the moment?
Yeah, so in the oceans, we started off on sailing ships. People would take a wooden bucket, they would lower it over the side, collect a sample of water, and if they had a mercury thermometer, they would measure in the bucket of water. Since then, it's become a lot more sophisticated. They then invented thermometers that could be just sort of dangled over the side of the ship that record the temperature. In places like the institute where I work, we started measuring in about 1902, initially using mercury thermometers. Then we went through a phase of having a network of volunteers around the coast where we would pay them 50p for every measurement that they take. Every morning they would go, while they were walking their dog or whatever, go down to the sea, dump the thermometer in the water, read it off, and then they'd send us a postcard with the temperature on. But for the last 20 years or so, things have become much more automated. So we now have a network of buoys offshore, which records temperature almost continually. We have gliders that travel around in the ocean.
Jug alarm's gone off. What's a glider?
It's a bit like when we talk about drones. It's a drone that's in the sea, so we program it, it records whatever we want, and then it might come back. And it bobs up and down, so it goes between the surface and the bottom profile. So we get a complete idea of the sort of temperature at depth. So at the beginning of the 1900s, we might take 1,000 temperature measurements in a year. But now, because of the automated platforms, We can get 1,000 measurements a minute, all beamed to us by satellite.
Thank you. So, Susana, John's kind of hinted at some of the impacts of temperature on the marine environment and some of those changes. Can you go into a bit more detail of how changes in temperature affect the marine environment, please?
The oceans are a challenge, and they are so interesting as well for us as scientists. They cover much of the surface of the Earth. They are vastly unexplored. They are highly dynamic. There is always waves. There is always tides as well. Daily cycles, daily changes, seasonal changes. There is currents, almost like rivers running across the world's oceans. Some of them run over the surface, some of them bottom, and they are almost conveyor belts and transport heat and nutrients and oxygen all around. They are constantly changing. Different to land environments, they have a third dimension. So things in the ocean don't just move across, they also can move up and down. So all of those changes and the vastness of the ocean and the fact that we don't know enough about them are a challenge. So you've got those long-term changes that are gradual. There is also sometimes sudden events, extreme events. They can be storms, marine heat waves, for instance. Then there is the fact that different species and different habitats will respond differently to environmental change. So some are more tolerant, some are more sensitive. It's important to understand all of that to then be able to understand what is the impact or what is the risk of this climate change, because it doesn't affect all of the ocean environments or coastal environments in the same way.
So you've got the scale of the ocean across the whole of the planet. We are a blue planet, inaccessible aspects, and you've got the complexity. So it's a really big, complicated system, and thank you for describing so many aspects of that. So shall we dip into two examples, perhaps? An example of an environment that reacts to temperature changes and an environment that might be more vulnerable. Can you go through two examples?
So at the poles, these are some of the hotspots, climate change hotspots on Earth at the moment.
I just wanted to define what you meant by a hotspot. So it's not that the polar region is the hottest spot, it's actually the most important change in temperature that's been detected.
That's right. It's almost an idea of the risk that in those areas.
For example, scientists have identified 20 hotspots around the world, and these are the areas that are warming the fastest. And actually, the North Sea, for example, is one of the 20 hotspots for marine climate change that have been identified around the world.
But you wouldn't want to go swimming on there on a winter's day necessarily, because it's not likely to be hot.
No, at the moment it's about 10 degrees.
It's on that list of ones to watch, I guess.
Yeah.
So polar areas, before I interrupted you.
I mean, the most obvious change that is taking place there is the melting of the sea ice. So every year in winter, the sea ice forms, but every year the extent of the sea ice is getting smaller and smaller. And in summer, the temperatures are getting hotter and hotter. There is so much wildlife there. They are so finely tuned to that particular environment that these changes are catastrophic. And then there is the other changes that are maybe less obvious and less visible is the sea itself. That's actually even, affecting the entire planet, because that is causing the sea levels to rise all across the world. And that is affecting all of us. They are key environments, and the changes that happen there have repercussions all over the planet. And then we said we were also going to think about the hottest seas already. So these are the seas, for instance, around the Persian and Arabian Gulf, the Red Sea. They are not very big, and they are surrounded by land in arid places as well. So it's already quite hot. So these are the seas that signal what other seas around the planet might see in decades to come. They have things like coral reefs, and they have species that are very tolerant to high temperatures, but climate change is pushing them to the edge of how much they can tolerate.
So what are some of the climate change shifts that we're seeing in around our own coast?
We have, over the last few decades, around the seas in the British Isles, we have also seen quite dramatic changes. So, for instance, higher temperatures in the seas are causing the plankton, the composition of the plankton is starting to shift, and that has a knock-on effect on the things that feed on the plankton, on the fish, for instance. We are also seeing fish starting to move away towards more northern areas, other fish that are more from places further south, even from the Mediterranean, sardines, anchovies, they are starting to come up because they follow the warming of the water.
So as the climate changes, different groups of animals are moving where the optimal temperature is moving.
In a way, they are adapting to those changes, aren't they? It's us who are struggling to come up with ways to adapt ourselves to those changes because, we can't just move home every time the temperature rises like sometimes animals do.
So Susana has mentioned how people are having to adapt. How are we already adapting to climate change?
Yeah, one of the things is that we're having to think about whether or not we as consumers might want to change the fish that we eat. As Susana says, the fish are shifting their distributions. So in the UK, we have a tradition of mostly eating cod and haddock. But those are two of the species that are really shifting further north, and whereas we're getting a lot more warm water things that are traditional of the Mediterranean. And red mullets, things that you will have seen on holiday really, but only recently they've arrived here. And the big one that's arrived in recent years is bluefin tuna, which is showing up in quite large numbers off Cornwall and the southwest. And that means that also the fisheries that we have around the UK having to adapt to that. So some of them are changing what their catch is. So we've got new fisheries for squid, for example. At the moment in the UK, we tend to have very restricted sort of preferences in terms of what consumers want to eat. But maybe if we could broaden our diets a bit in terms of fish, eat more squid.
Battered calamari is lovely.
Yep. Yeah, and then there are other sort of things that we can do to adapt. One key adaptation measure is we're getting better at making projections and predictions about climate change. We now have early warnings of extreme events from the Met Office that regularly come out, whether it's temperature, storms or things like that. We're now better at building flood defences. We're better at designing where and how we should build our houses. A lot of our housing stock in the UK is over 100 years old. A lot of it's near the coast. Now we have to think about, well, where will the sea level be in 20, 30, 40 years' time? We've worked a little bit on insurance products, for example. So a few years ago, there were a lot of hurricanes hitting Caribbean islands, having absolutely devastating impacts on the fishing industry. One idea is that maybe there should be an insurance scheme so that if a hurricane comes along, the fishers can build back quicker, they can buy their equipment quicker, and that requires planning and agreeing what the action will be if a storm is above a particular threshold. And then simple things like design thresholds for buildings or fishing vessels, safety at sea. What do we need to do to make our ships or our buildings more robust? So they're all things that can be done and have been done all around the world.
So in what ways do changes to the ocean and the impacts of climate change on the ocean affect people?
It's sometimes easy to forget how strongly humans, wherever we live in the world, how strong is our connection to the ocean. Impacts on people can be many and varied. And what we do is we break down things into the services and the benefits that that particular society gets from the ocean. The biodiversity itself, which has got a value, an intrinsic value. The climate of the planet is regulated by the ocean. There is the food. So if climate change is having an impact on fisheries, as John was saying, there is already a risk to societies there. Even storms can disrupt navigation, the transport of goods by ship, for instance, across the ocean. So that's another way in which climate change can have an impact on people. We rely on the ocean for many forms of energy. There is oil and gas, fossil fuels, but there is now increasingly more forms of renewable energy that are based at sea, on the coast or offshore. So any disruption to that has an impact There is lots of materials that we get from the sea as well, sand, gravel, many types of minerals. So again, anything that can disrupt the operations, these things can have an impact on people and constructions, for instance. If we lose coral reefs, for instance, there is a lot of medicines that are based on substances found on these particular coral reefs, on the other organisms that live on the reefs, or sometimes the corals themselves. There is also all the spots, all the tourism that depend on areas close to the sea or on the sea. So there's so many ways in which climate change, by having an impact on the ocean, is then having impacts on societies. You have to sometimes break it down in this way to be able to understand it and then to be able to do something about it.
So we're all pretty reliant on the ocean in some form or another. So just when it's impacted by climate change, we will all be impacted. So we need to learn to adapt to these changes. So apart from temperature, how is the ocean affected by climate change?
The most obvious one is sea level rise. So sea level rise it's a result of the warming largely. So as we mentioned earlier, warming leads to melting of ice that's in glaciers, also ice sheets and shelves that are on Greenland and on Antarctica. So when that ice melts, it goes into the sea and the level of the sea goes up. But also the warming leads to an expansion of the water itself. And that's the thing that causes most of the sea level rise. Other areas that people might not be aware of are things like the carbon dioxide that we release into the atmosphere as a result of burning fossil fuels. Some of it dissolves into the ocean and leads to pH of the ocean becoming slightly lower, so slightly more acidic. And all around the world in recent years, we've noticed very, very small changes in the pH. And even though they might seem small, they can have quite a big impact on the ability of certain organisms to produce shells. So whether that's the skeleton of corals or the shellfish that we're used to eating. One further sort of non-temperature related thing that we're seeing is the amount of oxygen in the oceans. So as the temperature warms up, the ability of the seawater to carry oxygen actually goes down. And there are large areas of the oceans now where the concentration of oxygen that's dissolved in the water is much lower than it used to be. Even in some areas where there's virtually no oxygen in the deep waters. And then finally, briefly mentioned storminess. The numbers of storms that we see around the world isn't necessarily increasing, but the severity of the storms is. And that's true in the future, that we're predicting that the numbers of storms on average won't go up, but what we consider a severe storm is probably going to get worse. And that will have impacts on all sorts of human activities and industries.
So one thing you talked about there was emission of carbon dioxide, so CO2, into the atmosphere. So can you define why carbon emissions are so important and things like net zero and what that means for the ocean? Can you break down some of that jargon for our listeners?
The amount of carbon dioxide, but also other what we call greenhouse gases, like methane, which are incredibly important. We've been releasing those since the Industrial Revolution, but also from agriculture, not just industry. And it's important that we learn how to reduce our emissions. And one of the big targets that people talk about is net zero. And what we mean by net zero is to try and eliminate carbon emissions relative to the levels that were produced in 1990. So that's the agreed international threshold. All of our emissions are measured relative to the 1990 levels. So in the UK, for example, we've said that we'll try and get to net zero emissions by 2050, and we'll have reduced our emissions by 75% by 2035. Wow. And that requires quite a lot of changes in the UK. So in terms of the oceans, that's going to mean that we're going to see a lot more wind turbines in the sea. There's a lot of talk about carbon capture and storage. So where we've previously taken oil out of the seabed, one idea is that we should pump some of the carbon dioxide in the atmosphere into those voids and lock it away for the long term. It's quite a difficult thing to do, and there have been pilot projects. But in order to reduce our carbon emissions in an active sense, we're going to have to do something like that. You can do that naturally as well. So some marine habitats can lock up carbon for the long term. So things like seagrasses and mangroves, but also sediments on the seabed, they take in carbon dioxide, they lock it away, hopefully for multiple decades or even centuries. And so maybe we could improve the productivity of those sort of blue carbon, which is the sort of jargon word for it, sinks, to lock away some of the carbon naturally. And then finally, we need to reduce our emissions from vessels, from ships and fishing vessels. And that'll require real changes to the way that we power some of those vessels, just the same as on land. There's a move towards zero emission cars and vehicles.
So have we made any progress so far in some of those in the ocean already?
In terms of reducing emissions from ships and fishing vessels, all around the world, people are looking at electric vessels. For example, there's cruise liners out there that use sort of a hybrid technology. Sometimes they use electric power, sometimes they use diesel. Other ones are starting to use hydrogen and some of the more exotic fuels. In the fishing industry in the UK, we've already reduced our carbon emissions on average by about a third since the early 2000s. We're going to have to do more. We're going to have to look at alternative fuels, so things like hydrogen, but also ammonia as a stopgap, maybe liquefied gas or biofuels.
What do you mean as a stopgap?
So, for example, in the long term, you might want to go for things like hydrogen, which when you burn hydrogen, all you produce is water. But in the short term, it's quite difficult to move in that direction. So you might need to use fuels that are not entirely carbon zero, but are certainly lower carbon. People are starting to look at, you sometimes see it with cars, something called AdBlue, which makes the fuel burning of the engine more efficient. And so there are small things that we can do in the short term that don't get us entirely to zero carbon, but they get us partway there.
So we're well on our way. You know, we've recorded a lot of impacts that climate change is negatively affecting the globe, but we're already making some of those big leaps in reducing our emissions and improving our environment and helping with that adaptation that's having to happen. So it's quite inspiring, really.
But it requires planning, but there is hope, and we're seeing movement along those lines.
So John's already talked about a few different ways that we're adapting, and we're having new innovations and new ways and technologies that we're developing to help us adapt to climate change. So how can we understand the vulnerability of communities to climate change to then be able to utilise some of this technology that's already out there?
So when we talk about, for instance, vulnerability to climate or adaptation to climate, how we can adapt to climate, the first thing that we have to do is to understand the specific risks to each specific place. They are not the same. So then once we have that understanding, we can then look to how we can do things differently to overcome those risks. There is another word out there, resilience, climate resilience. So what is climate resilience? So is, again, doing things differently to allow us to overcome the impacts of climate change. And sometimes it's not about controlling climate change. Sometimes it's about controlling other things, other ways in which we use the seas, other pressures that we put on the oceans to allow the oceans to regain that strength. If it's a healthier environment, it's more likely that it will be able to overcome any impacts that come from climate change. It's the same for people. The better prepared we are, then we are more likely to be able to confront the things that climate change will throw at us. For instance, storms. Storms have sometimes dramatic impacts on coastal communities, but when communities are prepared for them and when they have early warning systems in place, the outcome is often better. In that way, there is so much we could learn from communities in small islands, for instance, both in the UK but also elsewhere. Usually, island communities are really tuned in to their environment, to the ocean. They understand the importance of the ocean because it sustains their lives, their livelihoods. They pass on this knowledge and they understand the rhythm of things, the natural rhythm of things. They have a sense of belonging. They look after the island and the sea around it. They are almost the custodians. So I think if we could learn from these, that could probably help understanding climate change risks a little better.
So we're getting to the end of our episode now, and the last part of the episode is our fun fact feature. Now, this is a feature that I like to summarise as a nugget of information or something fun that I can then go to a party or have a conversation opener and say, I've learnt this on the podcast. And it's kind of the last piece of information that our listeners can take away from this episode, because I think we've covered a lot and there's been a lot of information about the climate and how it's affecting us and the changes that are coming, but also some really good stories on how we are developing and how, as a human race, we are developing technologies to try and lessen those impacts. So what is your fun fact or your topic of conversation for our listeners?
Lovely story about mangroves, coastal mangroves. So mangroves are a special type of tree that grows on the edge of the sea. They've got these huge roots. They almost stand on their roots. They grow in tropical places. We don't have mangroves in the UK. But what they do is they also act, just like coral reefs, as a natural protective barrier around islands and coastlines in general. So there is a really nice story about Sri Lanka. So back in 2004, if you remember, there was the Indian Ocean tsunami. It reached all the way to Sri Lanka. It hit the country. What they realized is that where they had good, healthy mangroves, the villages behind those mangroves, actually, they didn't lose much in terms of both lives, but also property. But they realized how vital it was for the country to protect those mangroves. Sri Lanka was the first country in the world that pledged to protect all of their coastal mangroves. Ever since, they've been doing programs and they've been replanting them. For instance, women from the coastal villages, and they have all the seedlings in canoes, and they, one by one, they put them down onto the sediment around the established mangrove, just to make, to help them grow larger. The thing with doing it, we were talking about coastal defenses before, but when you have a natural form of defense, we call them nature-based solutions for the coast, you get so much more out of this because they give you all these other gifts. It's not just the protection of the coast.
And then nature-based solutions, is that what you mentioned? That's something that nature is providing many benefits to the local community, is that right?
That's right. And this is not just unique to Sri Lanka. So many countries around the world are looking to nature-based solutions.
Brilliant. So that's a really nice, lovely story to have and a lovely example to have in the back of our minds. So John, your turn for your fun fact or your topic of conversation for our listeners, the last nugget of information for this episode.
So for the last few years, I've been involved as a leading author on the Intergovernmental Panel on Climate Change's most recent global assessment. There was a really nice phrase that the UN Secretary General, and he said that every fraction of a degree matters, every voice can make a difference, and every second counts. So this is by far the biggest issue of our generation. But what he's saying is that everyone can make a difference. And hopefully some of the things that we've talked about might give listeners ideas of how they can adapt, how they can change their behaviour to improve the oceans and the environment in which they live.
Thank you so much. And it's so nice to have that real idea of coming together as a globe, try and solve this problem or adapt to this growing issue all together. That's really, really nice to finish on. So I'd like to thank you for being part of the podcast today. It's been really great topic to talk about, and lots of information and lots of interesting stories that you've given us. So thank you so much.
Thank you.
Thank you.
Thank you for listening. This podcast was made by CFAS, the Centre for Environment, Fisheries and Aquaculture Science. To keep up to date with us, follow us on social media using @CEFASGovUK. We hope you can join us again next time.